everyone, welcome to the channel. In today's class, we'll learn everything about the highest common factor, lowest common multiple, often known as HCF and LCM. And by the end of this video, you will know what they mean, how to calculate them quickly, their uses, and how to answer WAEC, NECO, and junior secondary school questions. Let's begin. First, let us talk about factors, prime factors, and the rest of them. What is a factor? A factor is a number that divides another number with no remainder. A factor is a number that can divide another number with no remainder or a remainder of 0. For instance, let us take 36 for example. What are the factors of 36? Can you tell me? Post your answer in the comment section below. I'll give you 10 seconds. Okay, these are the common factors of 36. These are the factors of 36. 1, 2, 3, 4, 6, 9, 12, 18, and 36. Why are they the factors of 36? If you observe, all of them can divide, like 36 can divide all of them with no remainder. Like 36 divided by 1 is 36, 36 divided by 2 is 18, 36 divided by 3 is 12 with no remainder, 36 divided by 4 is 9 with no remainder, 36 divided by 6 is 6 with no remainder, 36 divided by 9 is 4 with no remainder, 36 divided by 12 is 3 with no remainder, 36 divided by 18 is 2 with no remainder, and 36 divided by 36 is 1 with no remainder. Well done. Now we go into prime numbers. A prime number is a number greater than 1 with 1 and itself as its factor. A prime number is a number greater than 1 with 1 and itself as its factors. Examples are 2. Examples of prime numbers include 2, 3, 5, 7, 11, and 13. You can notice that these numbers cannot be multiplied by another, like another number cannot multiply themselves or any other number to give these numbers. These numbers are unique. There is no whole number that can multiply another whole number to give you a prime number. For example, 2 perhaps. You would say 1 times 2 is 2. Well, that does work. But for 3, it doesn't work. For 5, it doesn't work. 11, it doesn't work. 13, and on and on and on. There are infinitely many more prime numbers than this. Now we move on to prime factors. What are prime factors? Prime factors are numbers. Prime factors are numbers that are gotten when a prime number multiplies another prime number, no matter how many times they do it. Look at an example. 12. 12 is gotten from 2 times 2 times 3. 2 times 2, 4. 4 times 3 is 12. Other examples include 36, which is gotten from 2 times 2 times 3 times 3. And 64, which is gotten from 2 multiplied by 2 multiplied by 2 multiplied by 2 exactly 6 times, or 2 to the power of 6 in indices. Do not worry, every topic in mathematics, physics, biology, chemistry will be taught on this channel, step-by-step process. Now, we move on to our main topic, HCF, highest common factor. First, what is the highest common factor? What does it mean? The highest common factor, this is the largest number that can divide all numbers with no remainder. If you are asked to find the highest common factor of two numbers, then it would be the largest multiple or the largest number that is a part of those multiple that can divide all of them and that is common to both of them. Now let's take an example. The HCF of 36 and 32, how do we find it? First, we look for the multiples of both number. The multiples of 36 are 2 times 2 times 3 times 3, while the multiples of 12 are 2 times 2 times 3. And mind you, when I say times, I mean multiplied by or multiplies is just a fancy way of saying time and multiplication. So we find the number that is common to both of these multiples. Like we find the multiples that is common to both of them. And from here, we can see the multiples common are 2, another 2, and 3. Yes, the multiples common are 2, 2, and 3. So the HCF will be the product of all those common multiples. From this, we can see that the HCF is the product of 2 multiplied by 2 multiplied by 3, which is 12. So the HCF of 36 and 12 is 12. Now let us look at other examples. Now we will be discussing about these examples given. HCF of 48 and 96, HCF of 54 and 30, HCF of 60 and 30. Let us begin step by step. Remember, you can slow down the video from YouTube. You can slow it down as slow as you like till you understand. Remember, repeated reinforcement strengthens memory, and active recall is one of the best methods to use. Let us begin. The multiples of 48 is 2 times 2 times 2 times 2 times 3. Basically 2 to the power of 4 multiplied by 3. And the multiples of 96 are 2 times 2 times 2 times 2 times 2 times 3. Basically 2 to the power of 5 times 3. Now, we are to find the numbers common to both of these. The number common to both of them. This method, I would say it is the product of the common multiples. Yes, product of the common multiple method. These are the common numbers to both sides. 2, 2, 2, 2, and 3. That is to say, for the HCF, we will do the multiplication of all the common multiples between the numbers or in the numbers 48 and 96. Therefore, the HCF is, now from this you can see that the HCF is 48. How did I get 48? I multiplied the products. I multiplied the common multiple of both 48 and 96. That is 2 times 2 times 2 times 2 times 3, or 2 to the power of 4 times 3. Now, attention to detail is very, very necessary. As you can see, from the very first question, I did the HCF of 36 and 12, which gives me 12. And for the second, I did the HCF of 48 and 96, which give me 48. Now, this will lead me to another method. I'm coming to that real quick. I will come to that method, and that is the fastest method of doing HCF, or highest common factor of any numbers. Let us continue with question number 3. Now, for the second question, we have the HCF of 54 and 30. First, like I said, always find the multiples of both numbers. The multiples of 54 is 2 times 3 times 3 times 3, or 2 times 3 to the power of 3. And the multiples of 30 is 2 times 3 times 5. You notice how all these multiples are a product of prime numbers. That gives us a question, a very theoretical and profound question in mathematics called the Goldberg's conjecture, although it has not been proven yet. So we'll talk about that later. Now, as you can see, the numbers common to both of them is 2 and 3. So the HCF would be the product of the common multiples of both of them. So 2 times 3 is 6. Therefore, the HCF is Now, for the fourth example, we have the HCF of 60 and 30. What do? We find the multiples of 60 and we find the multiples of 30. Now, let's begin. Now, these are the multiples of 60 and 30. The multiples of 60 are 2 times 2 times 3 times 5, and the multiples of 30 are 2 times 3 times 5. What do we do next? We find the common multiple, or the multiple common to both numbers, and we do the product of all those multiples to get the HCF. Let us continue. From this, we can see that the multiples common is 2 and 3, and the HCF is 2 times 3, which is 6. The HCF is 2 times 3, which is 6. Now, I want to go into the first method of finding the HCF. It is called the Euclidean algorithm, or you can call it the division method. Don't be scared, it is not a big word. Using the Euclidean algorithm to find the highest common factor of 54 and 30. This algorithm, or this method, is all about division. First, I will show you how, step by step, and I will explain. Now look, first, we look for the smallest number in the HCF of those numbers. And the smallest of 54 and 30 is 30. Therefore, the first step is to divide 54 by 30. The answer is 1 remainder 24. Then the next step is to repeatedly divide the smallest number, that is 30, by every remainder until the remainder is 0. For instance, we have 30 divided by 24, which is 1 remainder 6. And 30 divided by 6 is equals to 5 remainder 0. Therefore, using the Euclidean algorithm, we can see that the remainder before the remainder of 0 is 6. That is, the second to the last remainder would be the HCF of 54 and 30, which is 6. Therefore, the HCF of 54 and 30 is equals to 6. Remember, 54 divided by 30, that is the largest divided by the smallest. And the smallest will be divided by every remainder after it until the remainder is no more remainders. 54 divided by 30 is 1 remainder 24. 30 divided by 24 is 1 remainder 6. And 30 divided by 6 is 5 remainder 0. Therefore, the HCF would be the second to the last remainder, which is 6. So the HCF is 6. Now, let us try this for 2 others, and the last one, you have to try it yourself and post it on the comments and let me see if it works. Prove it to me that it works. You will continue this and I will give you assignments. And yes, using the Euclidean algorithm for the second HCF of 48 and 96. 96 divided by the smallest number, which is 48, gives you 2 remainder 0. Now, there is a catch to Euclidean algorithm. If you were to divide the biggest by the smallest, and the very first instance you get a number remainder 0 or a number with no remainder, then the HCF is the smallest number. Yes, the HCF is the smallest number. Or you can say the HCF is the number in which you divide the big number by to get a remainder of 0. That is 30 divided by 6, you get 5 remainder 0. Therefore, that 30 divided by 6, that 6 is now the HCF. And now 96 divided by 48 gives you 2 remainder 0. Therefore, 48 is the remainder. It works just well. Now we are to look at the third example and the last example in HCF. Let us continue. And note, I have been giving you HCF of 2 numbers. You can have HCF of 3 numbers, 4 numbers, many more numbers. Okay, let us continue with the next one. Hope you understand my explanation. I said if you were to use Euclidean algorithm method or the division method, the big number divided by the smaller number, and every remainder, the smaller number will be divided by every remainder after it until there is no remainder. And the last remainder before, and the last divisor, which gives a remainder of 0, will be the HCF. My apologies, it seems there is a mistake in question number 4. The HCF of 60 and 30. Multiples of 60 are 2, 2, 3, and 5. Multiples of 30 are 2, 3, and 5. Therefore, the HCF should be 2 times 3 times 5, and which will give us an answer of 30. 2 times 3 times 5 is 30, which is 2 times 3, 6. 6 times 5, 30. My apologies. Now we continue with our Euclidean algorithm. Now, from this, we can see that 60 divided by 30 gives 2 remainder 0. And the last number to divide 60 for it to have no remainder is 30. Therefore, the HCF of 60 and 30 is 30. The HCF of 60 and 30 is 30. The last number to divide 60 with no remainder is the HCF. That is basically the summary of the Euclidean algorithm method, or the division method. Now, this one you are going to do it by yourself, the HCF of 36 and 12 using Euclidean algorithm. If you do not understand how, you can ask me in the comments and I will explain perfectly well for you. We are moving on to the lowest common multiple, or known as LCM. Lowest common multiple. Now, the LCM of numbers is just the product of their common multiple, much like HCF, except HCF is the highest common factor, while LCM is the lowest common multiple. Now, let us look into some examples. This is a method of finding the LCM of 12 and 36. The LCM goes by dividing both numbers by the smallest common multiple. What is the smallest common multiple of 12 and 36? That is 2. And yes, there is no order for you to do it. You can do it anyhow you want. However, it must be the smallest multiple. That is to say, you can do 4, like 4 in all of them. You can do 3 in all of them. You can arrange it in any order. There is no such thing as using 2 first, then using 3, then using bigger numbers. You can arrange them in any order of your choice. So remember, the LCM of 12 and 36 goes 2 in 12 is 6, 2 in 36 is 18, 2 in 6 is 3, 2 in 18 is 9. Then the next one is 3. 3 in 3 is 1, 3 in 9 is 3, 3 in 1 stays that way, and 3 in 3 is 1. Therefore, the LCM would be the product of all these numbers. The LCM is the product of all these numbers, 2, 2, 3, 3. Now, you don't necessarily have to do 2 in 12, 36 in 18. However, you have to take care that the number you are using can divide both these numbers, 12 and 36, without a remainder. Can divide them without a remainder, or a remainder of 1. No, without a remainder, I mean. So the LCM would be 2 times 2 times 2 times. Now the LCM would be 2 times 2 times 3 times 3, which is the same thing as 2 to the power of 2 times 3 to the power of 2, or 4 times 9, which is 36. 4 times 9, which is 36. Therefore, the LCM of 12 and 36 is 36. Now we look at another example. Another example should be 14 and 28. No, let's say 14 and 70. Yes, the LCM of 14 and 70. Therefore, the LCM of 14 and 70 is the LCM of 14. Therefore, the LCM of 14 and 70 is 2 times 5 times 7. That is the LCM of these common multiple, or the product of these common multiples, which is 70. The LCM of 14 and 70 is 70. Let us try one more and we call it a day, and I will give you one fun fact. Okay, one more. Now we look for the LCM of 126 and 300. The LCM of 126 and 300. Remember, LCM, you divide all these numbers by a common multiple for both of them. So let us start. 2 is common in both of them, then we divide. This is the LCM of 126 and 300. That is 2 in 126 is 63, 2 in 300 is 150, 2 in 63 would give us a remainder, therefore we leave it that way. Then 2 in 150 would not give us a remainder, and it is 75. Then which other number can divide or can go into 63 and 75 without giving us a remainder? The number is 3. 3 in 63 is 21, 3 in 75 is 25, then 3 can still go again. 3 in 21 is 7, 3 in 25 would give us a remainder, so leave it like that. Bring down the 25. Now we look for the next number. Note, you can start with 7 here, as I started with 5 here. However, you can start with 7 here. There is no rule confining you to starting with smaller to bigger. You can start with bigger to smaller, as long as the division of both sides or the division of both numbers does not give you a remainder. Therefore, the LCM would be the product of all these numbers. Therefore, the LCM of 126 and 300 is 3,150. It is 3,150. Hope you understand all we've been doing so far. And again, the LCM, they can give you the LCM of 3 numbers, 4 numbers, 5 numbers. So you use the same method. It is the same method. I will do one more concerning the LCM of 3 numbers. Only one more. Then we will round up. Now the method works for the LCM of 3 different numbers, 12, 16, and 30. Here you can see it works exactly the same way. The LCM would be the product of the common multiples in all of them, which is 2 times 2 times 2 times 3 times 5. And that gives us 120. It gives us 120. The LCM of 12, 16, and 30 is 120. We have come into the end of our lesson today. Now, for a fun fact, do you know that the HCF of a number of 2 numbers multiplied by the LCM of 2 different numbers is equals to the product of those 2 numbers? Let me show you what I mean. That is, the HCF of 12 and 36 times the LCM of 12 and 36 is equal to the product of 12 times 36. Now let us look at that. We have done this before. The HCF of 12 and 36 is LCM 36, 36, HCF 12. So you can see the HCF of 2 different numbers multiplied by the LCM of 2 different numbers with similarity, like similar 2 different numbers as the HCF, would give you the product of those 2 numbers themselves. Thank you for watching, and I hope at the end of this section you have learned what are prime numbers, prime factors, how to find the HCF using normal method and Euclidean algorithm or the division method, and how to find the LCM. Now, the last question, I leave you with an assignment. The assignment is do this yourself. The HCF of 36 and 12 using Euclidean algorithm. Thank you for watching. Like, subscribe, comment, and share whatever. Thank you. Thank you.